Hello there, it's a great day for maths. We are at notes 3.3b, page 3. Okay, so turn there and let's look at classwork C and D. So let's recall we are doing simultaneous equations by now the elimination method. Let's first label the two equations and then decide which variable is easier to eliminate. A quick glance, we will see that actually a good choice will be the x values. Both are positive x. So in this case, I am going to subtract equation 2 from equation 1. So I'll write down equation 1, x plus 3y, minus away left-hand side of equation 2. Don't forget the terms on the right-hand side. So equation 1, 6 minus 0. Expand it carefully to get x plus 3y minus x minus y equals to 6. And there you have it. You notice that x will be eliminated in this case, only to have just 2y left behind equals to 6. So therefore, y is the value of 3. Now place the value of y back into either 1 or 2, your choice. I'll put it into 2. What we will have is x plus y, which now takes on the value of 3, equals to 0. So therefore, x must be the value of negative 3. And we are done. Rounding it off, x is negative 3 and y is 3. Next, let's try part D. Let's first label the two equations and then decide x or y, which one is easier to eliminate. Yes, it's the y value. Reason is I have negative 3y and the other one is plus 3y. Just a difference of sign. So in this case, do you recall what do I do to the equations to eliminate y? Very good. I am going to add them instead. So 4x minus 3y from equation 1 added to 2x plus 3y of equation 2. Let's not forget the right-hand side, 5 plus 7. Now release the brackets and you will notice that, I will get this, and y will be eliminated because they will add up to 0. Okay, continue with x. I'll get 6x to be 12, and therefore x is, very good, 12 over 6, which is 2. Now substitute x equals 2 back into either equation. Let's try number 1 and see what we get for y. 4 times of x, which is now 2, minus 3y is equals to 5. 8 minus 3y is equals to 5. And now minus 3y is 5 minus 8, which is negative 3. So in the end of the day, y is negative 3 divided by negative 3 to be 1. And I conclude again, x is 2 and y is 1. Hooray! So this is 2 examples of elimination when I'm adding and subtracting equations to eliminate either x or y. Moving on. What happens if I have such a situation? Let me follow the same steps by first labeling equation 1 and equation 2. And I glance at x and y values of both equations and realize there is nothing in common between them. Or rather, I don't have equal numbers or coefficients of x and y such that I can just add or subtract immediately. Instead, now, let me just focus on x values. Since this is our equations, can I now do something to them to achieve a lowest common multiple of the numbers 2 and 3. Do you recall what LCM refers to? Just like in fractions, the LCM of 2 and 3 is actually 6. So that means what I'm trying to do is I'm going to take equation 1 and do something new to it. I'm going to multiply by 3 to get 6x minus times 3 to get 15y. Last term also multiply to get 36. So I have taken equation 1 and multiplied every single term by 3 to get a new look. And now I'm just going to call it equation 3. I'll just put an arrow to not confuse it with a minus 3. Right, so now I have to do something to equation 2 instead. To get the lowest common multiple of 6, I have to multiply equation 2 by 2 instead. So what happens is that equation 2 becomes now 6x minus 8y because minus 4y times 2. And I get 40 because I have 20 multiplied by 2. So you'll see that equation 2 now changes to equation 4. And we see that finally, after multiplying, the x values now have something in common. Or the x coefficients, sorry. Now what happens after this is simply the same as previously. I'm going to take equation 3 and I'm going to subtract away equation 4 to eliminate x. So I'll have 6x minus 15y minus 6x minus 8y is equals to 36 minus 40. Okay. So expanding it, I will have 6x minus 15y minus 6x plus 8y is negative 4. There you see that x is successfully eliminated and I'm just left with minus 15y plus 8y, which is a negative 7y equals to negative 4. Not very nice numbers to deal with, but I can still divide them accordingly to get y as 4 over 7. Almost at the end. Now I'll substitute y equals to 4 over 7 back into either of the equations will get you the x value. So I'll substitute it into equation 1. Okay, so 2x minus 5 times 4 over 7 is equals to 12. 2x is minus mixed number of 2 and 6 over 7 equals to 12. 2x is 12 plus 2 and 6, 7. Okay, not a very nice answer. To get 14 and 6 over 7. Finally, x is that fraction divided by 2. To finally get the answer of x is 7 over 3/7. And conclude, x is 7 and 3/7 with y as 4 over 7. Not the nicest values to get, but still possible. Alright, let's continue with the math of elimination method practice. If you're faster, you can actually give these questions a try instead of just listening to me and copying. Okay, so let's take a look. Equation 1, equation 2, which one is easier to deal with? You realize both are not direct numbers, like one positive, one negative. So you'd have to make a choice. Which is easier? You want to go for x or you want to go for y? I think personally that x is easier to deal with. Why is that so? Because right now I could just take equation 1 and I multiply it by 2 throughout. This will give me 2x minus 4y is equals to 10. So as you can see, equation 1 now becomes a new equation 3, and I just now compare and try to eliminate between equation 2 and 3 instead. Right now, you notice that, oh, now this x values are the same, 2x and 2x, the coefficients, sorry. And because now they're the same, I can take equation 2 and I'm going to subtract away equation 3. So I will get 2x plus 3y, subtracting away 2x minus 4y from equation 3. And on the right hand side, equation 2 of minus 4 minus a 10 from number 3. Okay, now simplify these terms to get 2x plus 3y minus 2x, and yes, positive plus 4y, I mean, equals to negative 14. So you can see how the 2x actually, or rather x values, get eliminated. And I'm left with 7y is negative 14, and therefore y is, very good, negative 2. So let's substitute y equals to 2 or negative 2 into your choice. Let's put into 1, okay, to get x minus 2 times negative 2 of y equals to 5. Multiply this out, I get positive 4 is 5, and so therefore x is 5 minus 4, which is 1. Let's conclude that x is 1 and y is minus 2 at the end. There you go. Right, you're in luck. B is exactly the same as A, so we'll skip that. I'm sure you're cheering. Let's move down. Okay. Part C and part D. Let's label first, as usual. Now decide. X or Y, which one is easier to find the lowest common multiple of? Okay, I hope you've chosen Y like me, because what I can do is aim for 3y for equation 1. So what I'm going to do is take number 1 and I'm going to multiply by 3 throughout. So I'll get 6x, because 2 times 3 is 6x, plus 3y, and 2 times 3 is again 6. So equation 1 now becomes a new equation called 3, and we will just concentrate on equation 2 and equation 3. Now you see that they have the same coefficient 3y, so I will take equation 2 and subtract away from each other. So I'll get 9x plus 3y minus 6x plus 3y. And on the right hand side, 5 minus 6. Simplifying it, I've got 9x plus 3y minus 6x minus 3y is negative 1. Y is eliminated, so I'm only left with 9x minus 6x to get 3x equals to negative 1, and x will be negative 1/3. Let's now place it back into either one. You choose. I'm going to choose number 1. 2 times negative 1/3 plus y is 2. This is negative 2/3 when multiplied out. And y will be 2 plus 2/3 to get 2 and 2/3. Concluding, x is negative 1/3 and y is 2 and 2/3. Hooray! Last but not least, equation 1, equation 2, label it and decide. Which one is easier to find the lowest common multiple of? To be honest, both are equally difficult. So I'll just pick x to be the one we'll concentrate on. Okay. So the LCM of 3 and 4 is actually a 12, right? So I'll have to take equation 1 and multiply it by 4. What will I get? 12x minus 4 times 2 is 8y. 1 times 4 is 4. So this becomes equation 3. Next, I'll take equation 2 and I'll multiply it by 3. So I'll get 12x plus 15y, and 3 times 3 is 9. And I'll get equation 4. So there you can see now I have a same coefficient of x. And now I can take equation 3 and I subtract away equation 4. So 12x minus 8y from 3 minus 12x plus 15y from 4. The other side I have 4 minus 9. Simplifying it, I will have this, and x is eliminated, only having negative 23y as the remainder. What a weird answer. When I divide it, I will just get positive 5 over 23. Let's substitute it back into 1 or 2, up to us. Let's put it into 1. I will get 3x minus 2 times of 5 over 23 equals to 1. 3x minus 10 over 23 equals to 1. 3x becomes 1 and 10 over 23, and x is finally, what a weird number, or fraction should I say, that number divided by 3 to get 11 over 23. So to conclude, x is 11 over 23 and y is 5 over 23. We are finally done. Hooray!